Hi, this is Austin with Radical STEM Tutoring, and today we're going to add some vectors. So in a lot of intro physics classes, you're going to have to work with vectors. So we have another practice problem working with vectors, converting them between coordinate systems to help get us accustomed to using them. So what we're going to do today is we're going to add these two vectors A and B. Now we have a few of the parameters given to us. We have this angle alpha that A makes with the x-axis is equal to 45 degrees. Then this angle beta that B makes with the line that A comes off of is beta equals 120 degrees. And we know that the magnitude or the length of each of these vectors is exactly the same. They are both 5 meters long. So what we need to do is get the resultant vector r equals a plus b and express it in Cartesian xy coordinates as well as polar r and theta coordinates. So, the easiest way to add a and b to get our resultant vector r is to express a and b in terms of xy Cartesian coordinates. Then we can just add the x components together and the y components together to get r. So, let's go ahead and start by expressing a in terms of Cartesian coordinates. So we know this vector a will have some x component, ax, and some y component, ay. Why don't we go ahead and draw a triangle to represent this, where this is the magnitude of a, this is our angle alpha, which is 45 degrees, then we'll have ax and ay over here. Now we can go ahead and put in that the magnitude of a is 5. So, let's use some trigonometry. If we want to get the side adjacent to our angle, remember from SOHCAHTOA, cosine will relate the adjacent side to the hypotenuse. So that tells us cosine of 45 equals the adjacent side, ax, over the hypotenuse of 5. And then we can just multiply by 5 on both sides to get that ax equals 5 times the cosine of 45. And that comes out to 3.54 meters. Now we could go ahead and calculate ay the same way, but we can use a handy fact about 45 degrees because that is exactly in the middle of this 90-degree range. The ax and ay sides should be exactly equal. That means ay also equals 3.54 meters. So we can go ahead and put these up here in our vector brackets. Now before we just write 3.54 in the x spot, let's take a second to remember that it's pointing in the negative direction. So that's actually going to be negative 3.54 meters in the x component, and over here for y it's pointing in the positive y direction, so that is just 3.54 meters. Now to get b, you know that b will equal some x component and some y component, so let's draw a triangle for it too. Now this one is not as straightforward as A because we don't really have the angle that's inside of here. There's probably multiple ways you could go about getting this. What I think is going to be easiest is to call this some new angle, theta, and then because this makes a straight line, alpha over here, coming off of that, beta over the top, and then theta on the other side, we can say that the sum of those three angles is 180 degrees, because a flat line has 180 degrees across it. That's alpha plus beta plus theta. Now alpha is 45 degrees, beta is 120 degrees, and then there is theta left over. And if we subtract 45 and 120 from both sides, then we'll get that theta is equal to 15 degrees. Now we can just do this the same way as before. Remember that this is 5 meters, then we can use the cosine function of 15 to equal the adjacent side bx over 5. So if we multiply by 5 on both sides, we get that bx is 5 times the cosine of 15. So bx comes out to 4.83 meters. And now we'll actually use the sine function since it's on the opposite side. Since sine relates the opposite to the hypotenuse, we get by over 5. We'll multiply on both sides by 5 to get that by equals 5 times the sine of 15, and that comes out to 1.29 meters. So we'll go ahead and write those in. 4.83 meters, 1.29 meters. And it's pointing in the positive direction for both of those, so we don't need to change any signs. Okay, now comes the easy part. R equals A plus B. Now all we do here is we take the x component from both of them and add it together to get our new x component. It's negative 3.54 plus 4.83 is the x part of our resultant vector, and 3.54 plus 1.29 is the y component of our resultant vector. And that comes out to 1.29, 4.83, both in meters. Now, let's go ahead and express r in polar coordinates in terms of a length and an angle that it makes with the x-axis. So, we can go ahead and calculate the length. R is equal to, what we always do is take the square root of the two side lengths squared. So that's 1.29 squared plus 4.83 squared. And that comes out to 4.9999, so we'll just say that's 5 meters. Now to get the angle that r makes with the x-axis, let's draw a triangle. So there's the angle we're looking for. These are our two components, 1.29 in the x, 4.83 in the y, and here is the length of r, which is 5. Now you can use any trigonometry function that you want to use. I'm going to use tangent. The tangent of theta is equal to the opposite over the adjacent. We get that from our TOA, T-O-A, opposite over adjacent. 4.83 over 1.29. So if we take the inverse tangent on both sides of that, tangent inverse will cancel out the tangent, so left over here will just be theta. So theta equals whatever number this is out of our calculator, and that's going to come out to 75 degrees. So, that's it. These are our two answers for the resultant vector. These both mean the same thing. If you go 1.29 meters in the x direction and 4.83 meters in the y direction, that will take you right here to the end of these two vectors added together. Or, if you go 75 degrees up from the x-axis, and then you walk 5 meters out, you will get to the exact same spot. So that is how you can add vectors together and convert them back and forth between Cartesian and polar coordinates. If you found this video helpful, please like it and share it. Have a good day.